but I mean the main one is in King's College London, and you can find the site here, and it tries to kind of get people interested in this kind of interdisciplinary researches to be a part of this network, and kind of encourages debates and meetings and so on. And many of us are already member of this, but I mean if you are interested, you would be most welcome to join. And of course you can contact her in her name, but I mean there are contact sites given here, and you can contact in various nodes. And so this is for your information. And then I would like to start. Hello, can you? Yeah, my presentation. Now my presentation will also have that's here. It is loaded here. So you get it now. Yeah. So this is this one. So yeah. So it will be essentially a very small thing that also needs further analysis, but I will try to indicate some of the observations. But before that, as it was mentioned, this genesis of this meeting was when the organizers of this meeting had planned for an issue, a special issue on can economics be a physical science, and published a large number, I mean collected a large number of review articles. Yeah, thank you. And yeah, and then they published that volume, and yeah, okay. So I would like to say, I mean, I do not expect that you have read that. Essentially, what I was trying to tell in that paper, I contributed a paper in that issue, and that more generally, I do not think economics has any kind of excuse to be outside natural science. Now, why do I say so? Now, epistemologically, our knowledge of truth is validated by two kind of means. Both can be generalized logic. One is the deductive logic, where I mean you deduce from one statement the other, which is being called as a truth, and because you start from another thing, and if you take that as a truth, and if you can come to this, then of course it is the truth. Now that you can use linguistic form of logic or more condensed form like mathematics. Now mathematics is just condensed form of logic is not new. Actually, it started with it had a long history, and essentially about 100 years back, I mean, or maybe a little less. I mean, Whitehead and Russell, in a series of 3 volumes published from Cambridge, the Principia Mathematica, they tried to show at least and prove that almost all of algebra is surely, and they actually said that it is tautology, in the sense that, for example, to find the truth of the statement that a bachelor doesn't have any wife, you don't have to check each and every bachelor and check whether he has any wife or not, because the first part of the statement talks about confirms the second part. Now, to say that mathematics, for example, arithmetic is just that, is not very far. I mean, you can easily kind of say that. I mean, something like 2 plus 2 is 4 because of the same reason. Because 4 has the definition. There's a set of 4s has got all the sets of 2 together with 2, or maybe 6 minus 4 is also there. For it, you do not have to check. For example, I mean, and this is true by definition in some sense. I mean, if there are some 50 or so people here, and if, okay, maybe if one gets in, so this is 51 now. I don't have to check whether yesterday it was true and today it is true or not. I do not need any laboratory to check this mathematics. Not only this mathematics, none of the mathematical truth requires any observation in the lab, or for that matter, to look at the nature whether it is true or not. So mathematics is true because of some internal structure. But physical sciences are not. That is mostly because, or natural sciences, because you have an inductive logic. I mean, you look at the nature, or you can do some experiment and then check somehow statements like this. Say the sun rises in the east every morning. Now that may be a tautology, because east may be you define the east by where the sun rises, or morning is when the sun rises. But if it says that sun rises every 24 hours on the east, then it is not a tautology, and you have to check, and it is a tentative truth. So far it worked. If it doesn't work, we have to find out what is the cause. That means I have to associate another phenomenon or observation or truth, and then try to comprehend whether this change is commensurate with that. Now that part is a part of natural science. Now, does economics try to belong to a different category? I mean, if it is a truth about some phenomenon, whatever difficult it may be, or whatever different it may be, it is about nature. Society, human society is not outside nature, and it's a natural system. It has a dynamics which may be difficult. Surely it is much more difficult than perhaps just for some inanimate objects, the dynamics of inanimate objects, and that too a many-body system with various kind of constraints and so on. It may be a difficult thing, but it has no chance to be outside the scope of natural science. And that, I believe, also about econ of physics, I think there should be some statement should be made. I mean, these kind of classifications of physics, chemistry, biology, it is not there in nature. It is our creation. Human kind of attempts in order to, like the caste system we had or the religions we have developed, it is actually our creation. It is not given by nature or God. We created this. Our upbringing created this. Physicists we are physicists by some. It is very difficult to distinguish where physics goes to chemistry or to biology. In a spectrum, the wavelength changes, and you suddenly, of course, you realize that there has been substantial change in the kind of color perception. But in terms of wavelength, it is just a continuous change. There is no real discrete differences. Similarly, in physics, chemistry, biology, or for that matter, economics or social sciences, there should not be any. There is no difference actually. When it is actually physics, it looks like we have clear perception when it is physics today and when it is. I don't think many of the chemists would believe that there is a difference. Many of the physicists got Nobel Prize in chemistry. Some people even, one didn't attend the Nobel Prize ceremony because they thought it is physics and it was given in chemistry. But I think it is complete nonsense. There is no such difference. Similarly, when chemistry goes to biology, this happens. I'm sure someday it will be. Now, it will be also for social sciences. People will find hard to distinguish between where is physics and social sciences different. They are trying to understand, about truth of some system which has many similarities with physical systems. So it may be econophysics or it may be economics. And this perception, there is a very old Buddhist actually example that 4 blind persons touched various parts of an elephant. Some touched the leg, some the tusk, some touched the trunk of the elephant, some other the tail part or something. And they interpreted it differently, depending on their experience. Some thought it is an animated object, some thought it is a tree, part of a tree, some thought it is okay, so these are the things. But it is actually, those who could, if there would be a coordination, they could clearly see that it is actually the same thing, there is the same gene, and we have to find out that gene. From any part of the gene, that some part may be suppressed. If we take from my skin and if you take from my hair, it would be different. But some parts of gene are suppressed and some parts elsewhere in my leg, it is another part is suppressed. But it is the same gene. Dolly was created by taking from one body part. The whole body, animal was created from that part by reactivating all the parts. So you can do that. That way some part of the gene may be more prominent in physical systems, what we call physical systems today. Some part may be dominant in chemistry part, some part may be in biology, some part may be in economics. But it is the same gene and we have to find out that gene. So that way I think it is the same kind of story. Now, and there is no real difference. It is all our old creation like religion, caste systems and so on. There is no real difference. And if you go to a doctor, they will realize that there is no difference until the family members come and tell them they are different. And anyway, so let me just try to tell you one very brief thing. It has really nothing compared to this kind of major statement. But we just observed it. Probably it requires a much more detailed investigation before something can be concluded. But let me tell you that there are various sites. I just copied for simplicity, some of the pictures from our publication. This one, which is a very, very preliminary thing of a new journal which wanted to have some contribution. So it is. But anyway, so you can see that there are various agencies. And these references are not in number because from the text I just took this figure, and then of course there are references like this, number 37, 43, 45, 46, that's why. Otherwise there is no meaning for this. Because the caption says that this data is taken from 43, so I gave 43 and so on here. It may be repeated if the next figure also. Now this is Correlate of War project. So they collect some data. This is a social phenomena that we go for war for whatever reason. That may be economic reason, there may be other political reasons or something. But certainly a single person cannot go to the war until there is somebody else. But that would be fight. But until a large number of people are involved in it, it is not a war. And you have some statistics that there are various wars, and not every war has same amount of death, human death, number of human deaths. So this is one such data source. Then Peace Research Institute, Oslo, they probably give the Peace Prize. But anyway, they also have some data for prior data for, okay, prior data is here. So these are for wars, these are for war deaths from correlate of war projects, Uppsala conflict data program. So you can find that there are various distributions. And in fact, these estimates of number, I mean, I think correlate of war or prior, I mean the peace. So there are various estimates, I mean from the newspaper or from the government, the countries involved, you can find out they do not always give the number of deaths properly, because that would kind of affect their own population, that either they will get demoralized or sometimes they will make a big claim. So all these things are there, but they could see that the distribution do not change, and these are the different kind of estimates for the same war. Some are shown by green, some are shown by red, and some are shown by blue. So there can be a major difference in the estimates that are still there. Sometimes it is not so, and so on. But I would try to find out this. Okay, then there are also fatalities. I mean, it's not necessarily war, but I mean, kind of disasters that may happen. It may be flood, it may be storm, I mean, and so on. And again, the data are taken from some international database, and on that date it was retrieved. Okay, sorry. So it has come. Now you try to find out the number of deaths and the cumulative probability. I mean that means 10 to the 4 death and above. I mean here this is the number, and then 10 to the 5 and above number of people died, and this is the number. I mean frequency of such kind of events. 10 to the 6 number of deaths and above, this is the number, and so on. And here 10 to the 2 deaths and above. Now this may be battle, this may be conflicts, this may be war, this may be terror attacks. These are man-made things. And you find that there are various natural disasters like earthquakes, it can be storm, wildfire, miscellaneous accidents, and all disasters together. So again, the sources are given here and when they were retrieved. It's clear that bigger disasters, bigger conflicts are lower in frequency. That's of course intuitively obvious, well, or rather seems to be obvious, not intuitively, but I mean they seem to be there. But all these data seem to have a similar behavior in the sense that log-log plot, I mean this is actually a log-log plot, seem to show a power law behavior. I mean, it seem to show a straight line fall, and that means there is a power. Typically the probability goes down with the size of the event, which is now here just the number of deaths caused by them. Now earthquakes is the earliest one, which was, I mean, famous 50s. I mean, Gutenberg and Richter found out that, I mean, if you take the energy release as the size of the earthquake event, energy release is given by exponential of the, I mean, the Richter magnitude. You can easily see that Richter magnitude going up to 8 or 9 is the only observed thing. this may be some kind of amplitude, and the real energy released, I mean, from various underground nuclear explosion, we can find out that the amplitude in that Richter scale of the kind of oscillator is related to the energy that we know for in nuclear bombs, is exponentially related. So from there you can find out the power law, because the log of the frequency of earthquakes with Richter magnitude m goes down linearly with m. As m increases, the frequency of that kind of earthquakes decreases logarithmically, but the magnitude is related to energy exponentially. So you can put that, and that would mean that power law, the frequency goes down in a power law way with the energy released, elastic energy released. Here, and that was shown to be the famous Gutenberg Richter power law, and I will try to compare with that. But I mean, you see that here we measure in terms of the data so far, I mean, in the areas of these things, not in terms of the energy released and also the location or which country is affected. Just by the number of people killed in that event, and the event size is measured by the number of people killed in that, and their frequencies, actually goes down with the same Gutenberg Richter law kind of power law behavior. It is remarkable that, I mean, these are completely different things. I mean, we do it, and apparently we are, I mean, not individually, but all the countries are, I mean, people are in the community are always in fight mode, and there seem to be some people who are taking us to those wars. But still, after all these things, you have a distribution of human death and in those events, and you can find the frequency goes down in the same manner as in earthquake, but measured in, I mean, the frequency of earthquakes, which can be measured by Richter magnitude, the seismograph, and also you can measure with from there you can find out the energy released, and you can get the connection, the frequency of earthquakes going, if you replace this x by the energy, I mean, released, then you will get Gutenberg Richter law, and I will tell you the exponent. But you can see that a very rough estimate, and you can easily imagine that these data are not always very accurate. Many deaths are not reported perhaps, and so on. But for very big events, those things are probably here, so cumulative thing may be a little insensitive to the kind of minor problems that may be for smaller ones, but you can not avoid a kind of concluding that they seem to be following a power law behavior and with almost the same exponent values if you actually measure the event size by the human. So now let me kind of tell you that these are the various, I mean, this table gives some of the man-made things, and I think the lower part is actually for natural disasters, natural phenomena, which physical science physicists, geophysicists, or others, I mean, environmental scientists do study, whereas these are studied by political scientists and so on. And if you measure those exponents, so you get something like this. This power law is everywhere, it seems, and power seems to change from maximum value of 1.65 maybe, or okay, 1.8, and minimum is maybe 1.5, 1.48, okay, 1.65 to 1.48. Now remember, this is this data of finding this exponent compare from. This is not you cannot do laboratory experiments. Also, for the earthquake data, it is very, very difficult to really get the Richter magnitude, because you can see that various people because the epicenter is not always, you do not have the seismic centers around the epicenter always. Some of the biggest earthquakes didn't have anything. Maybe some US data or some Japan data, Junec, even from Junec data, which is one very well characterized one, and the California data do not agree about the magnitude. So there are problems. And and here it is even more, because people try to manipulate these numbers. Politicians try to manipulate the exact number of deaths, and in various cases, or the country as a pride or something, if not for the opposite killings. And they sometimes suppress the data, and so there are some errors in these things. What I tried to collect here, or we tried to collect here, is that you can see this from various literatures. So you can find that I have given the references. You will find as natural as a social development of the city, how the city growths are taking place, and the distribution of city sizes in terms of population and so on. Or firm growth. This is 12 is from Axtell. So the exponent, everyone is talking about power laws, and there are some natural things like, essentially, except for Pareto wealth distribution, which is a little higher side, most of these are around 1.5. It's possible that these are different, and this shows there are some different universality classes involved. The next one is my thank you. So I am in time. So what I am trying to tell is that this is very crude. This has no claim to be of extreme significance at this stage. But what we try to tell is that there are various ways of measuring in physical sciences, but all these things, particularly major events, that disasters that come to us, either what we call man-made and what we call naturally, it seems most of them have, of course, everyone towards the end, they have a fact tail, and the fact tail is a power law tail, and this power seems to be very close, but they may not be exactly same, and it is very difficult to say which estimate is the best one now. Even the Pareto tail exponents are not always very accurate. Again, there are various problems, but except for Pareto tail exponent value, most of the things seem to be around 1.5. But on the other hand, even if you do not agree to that, there may be a difference in the universality class. But if there is, now let me tell you the final thing, that suppose there is a power law with some singular exponent. It is not 1, 2, or 3. It may be 1.3, 1.5, 1.7, and so on. Now, if something goes, a function px goes as x to the minus 1.7, already it's diverging, and this diverging singularity is, has a singular behavior. If it is 1, 2, or 3, then after some derivations, you could say the inverse of the probability is an analytic function or a polynomial, but not here. And that says, now these power laws are extremely scale invariant functions. You do not have a kind of Gaussian behavior or something. Very recently, many people are saying the average is over. We talk of a bell-shaped curve, most probable size, and then most probable size always gives a scale in the system. Income distribution usually have a most probable size, and then there is a power law tail. The most probable size is given by the history of the country, the economic things that are taken. So that's the scale set. And exponential functions, gamma functions are very good examples of scale-dependent functions. But these power laws are scale invariant. So there is no typical size of the disasters, and that says it is scale invariant. And if it is scale invariant, it doesn't matter whether you are doing it in finding it in in your country or in our country. There is the real scale that we have our long history, or we have this kind of politicians, will not matter. I mean, it's actually, we have to go beyond that. We have to find why this scale invariant feature is coming, and why this singularity. And so that would bring probably that all these natural systems, so I mean, would probably the same natural kind of systems, whether some are called man-made, some other are coming to mankind but not made by us. Except that, I mean, we sometimes test our nuclear bombs underground, and that of course disturbs the whole thing. They may be responsible for this. So we may be responsible for all the storms we are creating, I mean, because we are burning out our forests and so on. But they are very, very indirect. But the thing is, you can find these numbers intriguing. Thank you. Yeah, Damien.
Do you have an explanation why you find exponent? Sorry, do you have an explanation about the value of exponent for example, wars and so on, which is at 1.5? I heard some people say that it's extremely exponent.
Yeah. Okay. For example, for example, okay, not this or okay, let me just go to the this number 2 for earthquake. Burridge and Nopop developed a nice model, I mean, in early 60s or so. I mean, you take a rough surface table, you take some wooden blocks, and then you have the blocks are connected by springs. So these are the, just a minute, I will, these blocks, whenever they are touching, I mean, this is actually the continental drift, is that wherever they are sticking, that's shown, that is that the blocks are connected to the table surface. And then there are springs, hook springs, and then you connect it to a motor, which is uniformly dragging it out. It's a relative motion. Instead of moving the table, they were moving a train of blocks, which are connected by elastic springs, because whenever continent is touching with each other, the plates, I mean, they are actually, there are some elastic forces, so you cannot. And this is actually otherwise a harmonic chain problem. You could easily solve these things. The only thing is the friction force is considered to be, I mean, they did the experiment, but the numerical thing that was done by, again in 2000 or so, Langer and others wrote a very nice review in Review of Modern Physics, and you just assume a nonlinear friction force which is velocity dependent. I mean, all these things are relative displacement dependent forces and linear, but then if you have this friction force, which is velocity dependent and opposite to the direction of velocity. Now, velocity dependent is a nonlinear because very high relative velocity would make friction force going to 0. So that way you can take a very simple curve and simple form of the nonlinearity. All this immediately showed that yes, you have a and whenever the large number of blocks are slipping, they were taking a photograph of the positions of the blocks, and from that relative changes there you could find out the energy of the train of blocks. And you could see that first few there would be a time to charge the whole system to come to a kind of self-organized state, and then there would be all kinds of block position changes and corresponding energy changes, which will be very big and sometimes small and then very big. And these big things, or whatever, vertical, almost vertical, because whenever it is sleeping, the time is very short taken. So it is almost vertical drop in energy. You can find out the distribution of those sharp drops. Sharp means almost vertical drops. So they would be considered as the tabletop version of the earthquakes. And you could find their distribution. Similarly, in numerical simulations by Langer and others, they found that this exponent is very close to 2. Indeed. Now, whether it is no analytic results are really available, except that, Buck, Tang, and Weisenfeld made this even more I think it was almost to the other extreme, that it's almost a trivial model, but it had non-trivial behavior. That you have the height variables. If the height goes beyond 4 on a square lattice, you have some sandpile model of heights, and then if the height topples, if the height goes beyond 4, all the 4 neighbors get one of them. Now, if the height at that point, and you are adding heights randomly, height means stress randomly at different points with time, slowly, and then they will topple further and so on. And now, if it is a finite table, then after some time these heights will come out of the system. So you go on adding at a constant rate sand or heights in the system, and what is coming out will be some avalanches of heights. It may not be on uniform rate. You can find out the distribution, and yes, indeed, that gives a power law, but that power is not 2, around 2. It's quite smaller compared to that. It's about 1.6 or something. So there are some examples, but in a sense, BTW is a model, is probably a generic form of this kind of dynamics. So there is a possibility that it is actually, we do not know that whether it's, this is observation, 50, I don't know. Okay, it is pair-Buck thing. Okay. So they give the experimental result as 2, and then they try to kind of justify their model, which doesn't give this number, but is very close to that. It is close to that. So there are various physical law explanations, but if it is 1.6, then why it is so different from what people are saying about wars? They are also finding about 1.5, maybe that's not 1.5, maybe it is 1.6. So maybe the same model is also in some kind of extended space, there is some kind of BTW kind of rearrangements going on, self-organized way of bringing us to that level, and then we start war, and then these wars can be of various sizes for various limitations. And main thing is there is no scale to, it can be a world war like, it can be with Pakistan on and even then there will be a lot of people who would be dying. Okay.
So let's end the speaker again.